Hi everybody. This is kind of strange for all of us, but distance learning can work in mathematics too. You'll just have to be patient with me as I learn how to do this. One of the things that I want you to be aware of is that I will expect you to do homework and hold on to the assignments. We'll be collecting the assignments after spring break, so don't panic about that. I will figure out a way to get those homework assignments from you. Now, we're moving on after what I said on my LLA about Chapter 9 tests being postponed. We're going to move on to Chapter 10. Now, what I'm starting with is Section 1. The assignment is already online, but I'm going to try to explain to you some of the things that are important for you to know in this first section. We're going to start out with a right triangle. Now, in order to indicate that it's always a right triangle, we put a little box there in the corner. Now, I have labeled this with a funny looking zero here with a line through it. We're going to call that theta. It's a Greek letter, and we're going to reference all of our angles with things like theta and other Greek letters like gamma or beta. Right now, this is the angle I'm looking at right here, and some of the geometry of a triangle is that across the complete triangle is the side here that we call the opposite side, opposite the angle we're considering. Now, you may or may not have used the word adjacent ever. It means alongside, and the side that is right beside the angle is called the adjacent side. And the reason I don't call this one the adjacent side is that it already has a name. It's called the hypotenuse. And in every right triangle, the longest side is always the hypotenuse. Now, I'm going to do something here that is very important for you to start memorizing. I'm going to identify some terms, and I'm going to use sine, cosine, tangent, and then I'm going to use cosecant, secant, and cotangent. Now the sine, it has its own definition. So I'm going to write that here. Sine of our angle theta here is equal to this side, the opposite side, divided by the hypotenuse. It is a ratio. So we write it out like this. Now, you're going to get tired of writing all that. So we do use abbreviations. Op, standing for the opposite side, and hyp, referring to the hypotenuse. So you'll see it even in the textbook defined like that. The sine of theta is the ratio of the opposite side to the hypotenuse. Now we're going to go to this one. However, instead of writing the word cosine of theta, we're going to allow you to write these three letters and then put this in. And it's still called cosine of theta. Don't say cos of theta or cos of theta. Actually tell me what it is, cosine of theta. And it's equal to the adjacent side divided by the hypotenuse. Just like that. But to save time, we go ADJ. We all know what that means. And the hypotenuse. So you have three of them right there, with this added at the last. The tangent, that's a long word, so let's chop that down to just three letters again. And I'll put in our theta. And the tangent is defined to be the opposite side over the adjacent side. So now that you know about these two abbreviations, I'm going to put op divided by ADJ here. Now, to be consistent, three letters for each of these. We need to make this also three letters, so I'll take this out. Now that's still the word sine. If you say sin of theta, I would direct you down the hall to the religion department. That has nothing to do with mathematics. However, I will expect you to be thinking and saying sine theta, cosine theta, tangent theta. Don't give me these little text words, sin, cos, tan. Now in your head you might think of them that way, but don't say them to me. It's offensive, okay? Now, let's continue on. We got some more here. So I'm going to come over here and do our cosecant of theta. Now you notice I wrote it here, opposite sine. This is actually the reciprocal of sine. Can you read that? Reciprocal of sine. So what does that mean? Well, it means I could say 1 over the sine of theta. But, you know, in the reciprocal, if I wrote this 1 over opposite over hypotenuse, that when I flip this over, it actually turns out to be the hypotenuse divided by the opposite side. So that is consistently done here. If we're going to use secant to be the reciprocal of cosine, I'm just going to flip that over for its definition. And similarly with cotangent, I'll just flip that over to be the reciprocal of tangent. So I'll write those here. Now, look, we have a problem. Do you see the first three letters of this word? They're exactly the same as these three letters here. So I can't do that. So we have a special one. We call it these three letters, but you know that's cosecant of theta. And it's written to be this kind of definition here. Hypotenuse is on top now over the opposite. So I'll write here now the next one, which is secant. And, whoops, I forgot to put theta in there. And this is going to end up being easy because it is the three letters, the first three letters, secant of theta. And that's going to equal, well, you know the reciprocal already. It's the reciprocal of cosine. So I'm just going to flip that over. Hypotenuse over adjacent. And you already know the cotangent. I'll write it out here, but it is the first three letters, COT of theta, and that's equal to the adjacent divided by the opposite side. So these are the definitions you must learn for trigonometry. I will be holding you accountable for those in testing as well as in the quizzes. So put these to memory right away. And this concludes my introduction to the first chapter. Part 2, I'll talk about some of the special angles, but you can look at that part 2 after you've digested part 1 here. Thank you.